Yeah, I'm Sean. I work at GIPHY. I'll be talking about an A/B testing framework we built for our search engine last year using Spark and Scala. Start with a little bit about me. I'm the search engineering lead at GIPHY. A little bit about my background. I've always been into kind of quantitative problems and mathy stuff and modeling, and I've kind of meandered around. I studied econ and physics, and then I was an analyst, and then did some data science work, and then data engineering, and now more search-focused engineering. You can follow me on Twitter, S_Quiggles. Last name's Quigley. A little background on GIPHY. We're the largest GIF search engine out there. We love GIFs, and the company loves GIFs. We like to throw them in our presentations, so there'll be a lot of GIFs in this presentation. Just some background numbers. About 300 to 400 million people see a GIF from us every day. We serve 3 to 5 billion GIFs per day all around the world. We service around 400 million searches per day. Our API powers GIFs all over the internet, on Facebook, Instagram, Snapchat, Twitter, Tinder even. There's actually a lot of funny internal stories of, we do employee reaction shoots sometimes, and sometimes those GIFs will end up in weird places on Tinder. There's some funny stories around that. We also have owned and operated apps for iOS and Android. We have GIPHY World. It's an AR app that was built last year using the new Apple AR kit. Why should you care about this talk? Like, what's the real purpose behind it? Just so for background, we built an A/B testing framework for our search engine last year. In terms of like the company, it's a fairly small team. We've got 20 engineers. Search team specifically that built this is 4 engineers. And we need to also, on top of that, frequently ship a lot of product and algorithm improvements as a team. So we need to invest very strategically in larger infrastructure projects. We don't want to be working with a lot of operational overhead. We don't have the bandwidth for a lot of those problems. So this is kind of talking about some of the lessons we had having to build this within those constraints, like building something that's still very scalable and reliable, but still can be done with kind of fast iterative development cycles, and having fairly minimal operational overhead. We do run most of our infrastructure on AWS, which makes some of that easier, but also as a team, like we're very close to the product, and we can't be spending a lot of time on infrastructure and just pure data engineering all day. So I'm going to start with a little architecture overview, and then I'll get into kind of some of the factors that led to being able to do this successfully as a project. So for the high-level architecture, a little bit of this is cut off here, but on the very top left, it's just like this is in the context of our website. There's a user browser running React.js. It's a back-end Django web app. It communicates to our like internal GIPHY API, which talks to a search microservice, which kind of fronts Elasticsearch and powers search results. And we also have this other thing on the top right, we call it the pingback microservice, which is a service specifically for collecting behavioral events, which we use to measure a lot of impressions and clicks and all the stuff, signals that feed into measuring performance and A/B testing. And that service actually validates the quality of events that come in against the protobuf schema. So everything has to kind of fit a certain standard. Then we have these two kind of sources of data. We have this back-end context within the API, like in terms of what was searched, all the details of the results that came back, the API key corresponding to the partner integration the search came from. And then we have these front-end events like impressions and clicks and hovers and everything users are doing with an actual result grid that they get. Both those get logged into the Kinesis Firehose. And then they end up in S3 buckets. And then we use EMR, a lot of Spark to orchestrate a lot of these analytics jobs. And we have something that's called the search sessions job. Kind of takes these two sources of these Kinesis streams, and joins them together and sessionizes them. So you kind of have the back-end context of the user request, and then all the front-end events. When you kind of have a session of what users did for every search, what time of day, like did they click, did they not, did they convert. And this search sessions job feeds into a lot of other analytics, and data scientists will look into this a lot to kind of come up with ideas for how to improve the user experience for the search algorithms. We have this other Spark job that reads that data, our A/B testing attribution job. It can kind of read all the data and the behavioral stuff that happened in a session, and then hash users into different groups, and kind of measure performance for different search algorithm changes. We dump those results into S3, and then we can ETL those into Redshift, which is kind of our final data warehouse, and use Looker to kind of create a lot of user dashboards over that. I'll show you an example of that here. So a little background here. This is an A/B test we ran last fall. Sorry, man, I'll get a little water. But this was evaluating using Google Cloud Vision. It's like an automated service for computer vision image detection. So it's kind of evaluating that as a source of automated tags for our GIFs. And you can kind of see in these dashboards, on the left you have all user groups. You know, you have the experimental group in light blue, and the control group in purple. And we also split it out by desktop and mobile in the middle on the right. And then you can see with this test from the very beginning, there was a pretty good differential in click-through rates for the experimental group, which is what we'd like to see. We'd like to see the changes we introduce have a measurable positive effect. You kind of see throughout the duration of the test, in both mobile and desktop, this was a sustained winner, which we were happy to see. We also kind of measure the statistical significance of this. We kind of take the Bayesian approach to A/B testing rather than the frequentist approach. It kind of gives us a little more of an intuitive feel for the probability that the scenario we're seeing is, a real winner. And from the very beginning, it was a pretty high statistical significance. You can kind of see with mobile on the first day, it wasn't all the way there. It was like maybe 95%, but as we got more data and it came in, it slowly converged on close to 99.99% statistical significance, which is great to see. So given building this thing, we were able to build this in the course of about 2 months and start running it on live tests, and we've used it for a lot of feature development in our search algorithms, and it's been a pretty effective thing. And I'd like to kind of talk about some of the factors that played into some of the success, some of them being technical choices, some of them being more general principles and beliefs we kind of followed as an engineering organization. First thing is kind of the principle of just standing on the shoulders of giants. I've spent so much work, great work, that comes from the tech community and leveraging a lot of that. I think the open source data ecosystem has evolved tremendously. I remember just 5 years ago, before Spark really took off, writing Pig and God forbid having to write raw Java mavericks and producers to kind of just analyze some simple data. Nowadays, you just get so much amazing tech for free, and I think we kind of take that for granted sometimes. It's really evolved so fast, and it's kind of all at our fingertips to use. Another thing is just kind of go with the flow. We try not to reinvent the wheel. There's a lot of great momentum in different communities out there, and kind of just playing by those rules and using that tech leads to pretty good, reliable production systems. So we use a lot of Spark. Spark's for data engineering and data science. It's really kind of a powerful tool that we love. We use Parquet a lot. If you're not familiar with that, and I'm sure most of you are, but it's kind of a columnar, highly optimized format for analytics. It's also kind of become like the de facto format for Spark. So using it within Spark is really easy, and it's compatible with a lot of other data tools as well. We also use protobufs for upstream. It's like a kind of an interface definition language between services, and it provides a flexible schema, but some nice structure and compile time guarantees. Another thing we use is kind of monorepo principle. So the whole idea behind that is really having one giant monolithic code repository. It sounds kind of like a terrible idea at first, but once you start, there's a lot of advantages to it. We use a tool called Pants, and there's these kind of build tools specifically designed for managing monorepos. So what gives us the ability to have very fine-grained dependency management and kind of pretty fast builds for specific services and tools. Provides multi-language support for Scala, Java, Python, C++, Go, JavaScript. Some other examples out there like Bazel, Buck, Learna, some other ones. But a lot of the advantage of this is we can kind of have shared code in the same repository between like our upstream services, like our search service, and then also our downstream analytics and Spark jobs. You don't have to worry so much about having different repositories and incrementing the version on some library and revving that version across all the places that also use that library. And it's all in one place. And that's one of the big selling points of the monorepo. It's a principle and a lot of places have adopted, like Google and Facebook. And so here's an example of kind of one of these advantages. Like in our code base, we have this shared library where we can define in Scala a user per group for an A/B test. So there's kind of two different instances of this enumeration. There's a control group where there's no new change to users, and then the experiment group where we roll out the percentage of users, some kind of change. So then this kind of user group enum can be used in two different places. In this case, we can use it in our actual Spark job when we're doing the attribution for the A/B testing performance. We can filter our actual search sessions based on the user ID and the control group and the experiment group and calculate performance metrics across those two groups for our analysis and evaluation. But then also in our actual live search service, when user requests come in real time, we can, given that user ID from that search, we can hash them into that group and give them the control or the experiment experience in their search results. Another thing we really like is having type safety. We use Scala for a lot of things, obviously in our production services and also in all our Spark analytics code. Having those compile time guarantees saves us in a lot of cases. And especially as the code base grows, we have more reusable components and things that depend on the same stuff. Just having that, those compile time errors bubble up rather than runtime errors makes things a lot easier. It also allows us, we don't have to spend as much time unit testing. We're still big believers in unit tests, and we write plenty of them, but we don't have that need to have to unit test every possible little code path, because Highlevel will handle a lot of that. We also use the dataset API in Spark a lot, which is kind of the best of all worlds. It's type safe, it's very functional, and also very performant. Not too familiar with that, kind of the evolution of data sets. In Spark, there's first RDDs and data frames, and now data sets is the latest thing as of, I think, 2 years ago. RDDs in phase one, they were functional, they were type safe, but they were there's a lot of JVM object overhead defining these raw JVM objects in a distributed data set. And then they kind of came out with this data frame thing in phase two. It was inspired by pandas and had a lot of SQL-like functionalities. And then they kind of overhauled the whole engine for more performance. They have this Catalyst query optimizer that's really smart and highly performant. This Project Tungsten provides a lot of performance boost via things like code generation and more explicit memory management to get it closer to bare metal performance on the JVM. But the downside here is it's not very type safe. You can get a lot of weird runtime errors, and you kind of have to cast things here and there, and you don't get those same functional compile time guarantees you got with the original RDD data set. And now in phase three, we have data sets, kind of like RDDs on the data frame engine, so you get the kind of that functional Scala type safety of RDDs, but the engine and the performance of data frames. And data frames are actually a subset of data sets now. It's a data set of type row. Just one note to make the dataset API is not perfect. There are little annoying headache things. Like a lot of times, if you are using more custom data types, you have to specify these kinds of implicit encoders. Like this is a cryo encoder we have for our search session objects, which it works, it's fine, but it's not perfect. Another principle we like to follow a lot is having very flexible schemas. Our JSON spec for pingbacks, which are these kind of front-end events that come from web browsers or mobile clients. It's make it very flexible so clients can optionally batch as they want or send per event. We also like to have some upstream data validation in our pingback service. We have a protobuf spec that data gets validated against, but there's a lot of optional fields, so it's still flexible. And And then using protocol upstream and Parquet downstream, both formats can evolve and are flexible for changes when we need to add new fields or deprecate old fields. The final principle that made this kind of a successful project for us is just trying to keep things as simple and constrained as possible. Avoiding perfectionism, there's the old saying, perfect is the enemy of good. Some of the things we did to really keep it simple, for example, for our A/B test and analytics, we went with a batch format rather than streaming. Like streaming would have been nice, but for A/B testing, the batch format actually lends itself fairly well because you don't want that instinct to constantly be watching the performance of a test and turning it off when you meet certain statistical thresholds. You really should just have a set amount of time and wait till it's over and look at the final results. We also just went for A/B tests for now. We didn't try, we would like to move to more fancy stuff like multivariate testing and ABN testing and multi-arm banded testing, but for the first batch, we just needed really simple A/B tests. Another thing we did is the actual tests themselves, we just configured them in code. We thought of having maybe a separate data store or service or configuration file, which would have had some advantages, but it also would have added infrastructural complexity, and that, so far this has worked quite well for us and made it kind of smaller and easier to deploy. Some of the future work we're looking to do with this A/B testing framework is add in support for things like multivariate and ABN testing. We'd like to try expanding into GIPHY products outside of pure search. And also on the search team, one thing we're really working on is having more context-specific query models for search, like kind of having different models for a web user versus a messaging user, because there are kind of different demands. Sometimes in a web case, you get a very large grid of GIFs, and people like to maybe explore a little bit more. It's more of an exploratory context, and then in like a pure messaging context, you're getting like this small scroll of maybe 3 initial GIFs in the viewport, and it's really relevance focused. People want exactly what they search for, so they can send that GIF to whoever they're talking to. Last thing I'd like to say is GIPHY, we are hiring. We're making a big push to really expand out a lot of our search team, our analytics initiatives. If you go to boards.greenhouse.io/GIPHY, you can see a lot of these job postings. We're looking to hire a data scientist, data engineer, 2 search engineers, and an ad products engineer that would work fairly closely with the search team and building out a lot of the infrastructure and analytics for our ad products. Yeah, I just want to say thanks, and any questions? Yeah.
I want to see this architecture.
Okay. This is the final one.
So in here, where is the feedback loop? How does the
feedback loop between like a live search request and the downstream analytics?
Yeah, the choice that's made in the A/B test.
Okay. So it's not super clear, but if you see in the blue that search microservice, that's as the request comes in, it has a user ID, and we can flag and toggle that experience. And then in our actual A/B testing attribution job, it's using the same shared library for hashing a user ID between the different experiences. So based on the user ID and the time, we can deterministically know in a live service when the request comes in, and the downstream analytics, because they have the same user ID. So those experiences can match up.
Okay, so everything that's in blue is what comes back to the user, and then beyond that is the analytics.
Blue is all the live services and hops that go through, like I sync the live user request, from the browser or the client to our web app and our API and our search microservice. It's how those results get delivered. And the rest is more data infrastructure for collecting this data and the downstream analytics for it.
I'm really curious if there have been any, you're handling a lot of traffic and a lot of requests.
Yeah.
Has everything gone smoothly?
Most part. I mean, there are sometimes, like when an upstream client will push out some change, it'll break some data collection. So there have been outages and issues. Sometimes with the A/B testing, it's not as big an issue. It's like as long as whatever change that may cause data loss is kind of the same effect. It's not biased by the controller of the experiment group. If your data loss is evenly distributed across the two groups, it doesn't impact the results as much, but there can be some weird, like we did when we first rolled it out, there was some weird hashing bug. I can't remember the exact details, but in this like really weird edge case, like one of the, I think the experiment group would get heavily biased if some issue happened. So we ended up fix that with our hashing.
So those shared Scala libraries are really important to get right. Sounds like. Okay.
Yeah. I mean, it helps that they're shared. When we first rolled this out, it was actually before we had a search microservice, and our API is actually PHP code, and we had a library for hashing in PHP for the live request, and then downstream a Scala library for it, and we had to keep those and like make sure they were in perfect sync. And it worked initially, but once we had like a dedicated microservice in Scala, we just have the same shared code, which helped a lot.